thousands of witnesses have claimed to see UFOs, and their accounts are often strikingly similar.
You have a crash saucer, but also some crash bodies. You have government cover-up.
Mainstream science says the evidence just isn't there.
Oh my God.
It's a big jump between a UFO and an extraterrestrial spacecraft.
But if UFOs were really extraterrestrial craft, what kind of mind-bending technologies would we find under the hood?
You'd have to have some sort of technology that was capable of canceling the effects of inertia.
When it comes to unidentified flying objects, what is the real deal? For millions of believers, it all began on June 24th, 1947. A businessman and pilot named Kenneth Arnold is flying solo near Mount Rainier, Washington. Suddenly, he sees a group of 9 aircraft moving at incredible speeds.
They were highly reflective, and they were flying at supersonic speeds, in formation, changing course abruptly. The speeds were unattainable at the time. This was before the age of jets, and certainly supersonic jets.
Being a trained pilot, he did several things to corroborate their existence, to make sure he wasn't seeing some kind of atmospheric effect. He changed his head angle, he changed the aircraft angle. He even positioned the aircraft such that there was a light snow in the background behind the objects, and they appeared dark against a light surface.
Before Arnold can maneuver closer, the objects are gone.
It was basically unprecedented in modern times. No one had seen anything like this.
In the days that follow, newspaper reporters misquote Arnold as he tries to make sense of the incident.
In fact, he said it moved like saucers skipping on water. Now, of course, the reporter kind of messed that up in reporting it and said that they looked like saucers.
The term flying saucer is born, and Arnold's encounter launches the modern UFO phenomenon. Weeks later, in the summer of 1947, perhaps the most famous incident involving an unidentified flying object is reported near Roswell, New Mexico.
Roswell's become the poster child of the UFO phenomenon because it has all the necessary ingredients. You have a crash saucer, but also some crash bodies. You have government cover-up. There was some sort of cover-up. There was misinformation given out by the authorities.
The original account put out by the Air Force at the time was that this was a flying saucer of alien origin, and then later very quickly was denied. And the story then was that this was a weather balloon which had crashed, and that there were no occupants on board, and that there was nothing extraterrestrial about it.
Other witnesses claim to have seen actual pieces of a crashed spacecraft, materials that are reportedly unknown to science. Both Arnold sightings and the Roswell incident remain officially unconfirmed and highly controversial.
Just about every year, there are thousands of reported sightings, mostly in the sky, of objects that they assume are extraterrestrial craft, so-called UFOs. The U is important, of course, they're unidentified.
I personally have seen a bright light start at the horizon and shoot off into the clouds. Now, strictly speaking, that was a UFO. It's a big jump between a UFO and an extraterrestrial spacecraft.
Scientists argue that most UFO sightings either have earthly origins, like satellites, balloons, and aircraft, or cosmic origins, such as meteors, comets, or even an especially bright planet Venus. But when a UFO sighting has no known explanation, could it be an extraterrestrial craft? And if so, what kind of technologies could possibly explain the behaviors that witnesses actually report? How would such craft be built? And what problems would they have to overcome?
A lot of the behavior of UFOs that people have reported are things that are beyond our current level of physics. Extreme rates of speed or extreme acceleration, extreme turn rates, things that just we're not capable of doing without extreme harm to a pilot or destroying a spacecraft.
Eyewitness accounts of super fast accelerations, lightning turns, and sudden stops seem to violate known laws of physics. But could aliens find a way around these laws?
So what we have to keep in mind here is the principle of inertia. That principle, stated first by Isaac Newton, says that an object at rest or in motion tends to stay at rest or in motion unless acted on by an outside force. So to generate these kinds of crazy changes in inertia, you'd really have to act on that object with an immense amount of force.
Following the same logic, a fighter pilot traveling near the speed of sound, attempting to make a 90-degree turn at the same speed, would experience something close to 300 Gs of force. The most that a human pilot wearing a pressure suit can manage without blacking out is around 10 Gs. If his physiology were remotely similar to humans, an extraterrestrial pilot undergoing a 300 G maneuver would instantly perish. His internal organs would continue moving forward and crush against the skeleton.
If they were similar to us, they'd probably have to have a way of injecting fluid, internal fluid, inside their bodies so that they dealt with this problem of their organs floating around inside. And if they were strapped in properly and cushioned properly, end up not having internal damage when they accelerated and decelerated.
To effectively cancel the inertial effects on the craft itself, the pilots might switch on a technology that is beyond the reach of modern humans.
So in order to cancel out the effects of a 300 G turn and not be squished by that amount of force, you'd have to have some sort of technology or a device that was capable of canceling the effects of inertia.
The device would have to manipulate the force of gravity, using a type of force field to counteract the gravitational forces that rule the entire universe.
This device you could turn on if you wanted to, then turn it off if you wanted to, or maybe it would come on and off automatically. This is high technology that's out of sight.
But if science can't yet explain how these craft could overcome the deadly problem of inertia, can it help explain their shapes? Particularly the most famous shape of all, the flying saucer. In the late 1950s, the U.S. Air Force tested the Avro car, but the design had poor stability and few aerodynamic advantages, proving that high speeds are unattainable for saucer craft in Earth's atmosphere. The delta wing, or wedge shape, is a far stronger candidate, a fact that is well known by modern military aircraft designers. In fact, the percentage of UFO sightings reporting a wedge-shaped craft have increased in recent decades, a trend that mirrors the emergence of swept-wing jets and even flying wing designs, like the B-2 stealth bomber.
The shapes that people have reported over the years have changed, with the most recent ones being more wedge-shaped. So really, people's accounts tend to reflect the most advanced aircraft of the time.
Beyond movement and shape, any attempt to explain the science of UFOs has to deal with the noise factor, or rather, the lack of noise. UFO reports consistently claim that the objects move without making any sound.
Almost all of these sightings, it's a real rule, there's no noise, which you would expect to hear from any fast-moving craft in the Earth's atmosphere, you would hear.
What actually happens is that you get what's called a sonic boom, and that's a special pressure wave that sweeps through the atmosphere along with the craft. So you're on the ground, and that huge sonic boom is a result of that pressure difference between the front of the aircraft and the back of the aircraft as it pushes through the atmosphere.
Could an alien craft somehow cancel out the enormous pressure wave that supersonic flight generates? The answer could lie in the technology used in the latest generation of digital noise-canceling headphones.
So there is such a thing as a sound canceling technology where you take a particular sound that you're interested in canceling and kind of broadcast the negative of that sound to cancel it out. Now, I'm not aware of any technology that's capable of doing that with shockwaves.
Canceling out the ear-splitting, body-shaking effect of a sonic boom would certainly require some advanced engineering skills. And if there is silence, what about invisibility? Some reports claim that UFOs simply disappear into thin air. One promising human technology currently being researched might explain such phenomenon.
There is a technology on the horizon which might change things visually, and that is a kind of light bending technology. As a class, they're called metamaterials. If you want to think about popular movies, think the invisibility cloak in the Harry Potter movies.
Metamaterials use combinations of polymer substrates, gold, and copper to forcibly bend electromagnetic waves around an object. The light is guided around the object rather than being reflected or refracted. But advanced materials, stealth capability, and mind-bending maneuverability would all come to nothing if our visitors were unable to get to Earth in the first place.
I'd say that the chances of another civilization making it here to visit us are pretty minuscule. But if they did make it, it would mean that they had solved a whole bunch of problems, including material science problems that we don't have answers to. So they'd have technology far beyond ours, perhaps even beyond what we've dreamt of at this point.
But scientists can imagine several ingenious technologies that could bridge the seemingly unbridgeable distance between the stars, including one explosive propulsion source that's so apocalyptic we might see them coming light years away. For decades, countless UFO reports have surfaced from cities and countries around the globe. But not all UFO sightings have been reported from the surface of planet Earth. On July 19, 2009, viewers of a NASA video feed from the Space Shuttle Endeavour reported seeing a disc-shaped object hovering above the shuttle's mechanical arm. Space-based UFO sightings like this have purportedly happened throughout the history of manned spaceflight. Unspecified cosmic phenomenon? Or could it suggest the possibility that huge extraterrestrial starships are cruising the Milky Way galaxy?
Space travel between the stars, it's a staple of science fiction, right? You see it every night on television, you see it in the movies all the time. But could we really do it, or could any species really do it? Well, the distances between the stars are enormous, really enormous. Interstellar travel doesn't violate physics. It isn't that you can rule it out and say, there's absolutely no way they can come here. It's just that it's very, very hard.
Just traveling from the Earth to Alpha Centauri, our closest neighboring star at nearly 4.5 light years, is beyond the reach of our most powerful rockets.
If an advanced civilization were to visit us from a distant star system, we can pretty much rule out that they would use chemical rockets to get here. Despite the impressive pillar of fire and smoke that we see during Apollo, Saturn V, or shuttle launches, chemical rockets don't get you very far in the solar system.
To give you some context for that distance, our furthest known space probe is Voyager 1, launched in 1977. It's been flying for 34 years at 38,000 miles per hour, and it's only now starting to leave our solar system.
If its destination were Alpha Centauri, it would take over 56,000 years to reach even the closest star system. To engage in interstellar missions on timeframes of a human lifetime, around about 50 years, we can see that we need to increase the speed that we can travel by at least a factor of 1,000.
Scientists have determined that the speed of light is a mind-blowing 186,000 miles per second, a spacecraft traveling the star system would have to reach a significant percentage of that speed, even to reach the nearest star. The biggest obstacle is weight. A chemical rocket exacts a huge weight penalty because its entire fuel supply must be carried on board.
We can calculate that even to reach 6% of the speed of light using chemical rocket fuel, you would need more rocket fuel than exists mass in the universe. So we really know that it's actually impossible to reach another star system using chemical rocket fuel.
If extraterrestrial visitations are even possible, their spacecraft must solve this problem. In 2011, NASA's NanoSail D became the first solar sail to orbit the Earth. The ultra-thin 100-square-foot sail uses sunlight, or photon pressure, as a source of propulsion.
One of the immutable limitations of rocket propulsion is the fact that any rocket has to carry its fuel with it. A solar sail can take advantage of the naturally occurring resources, namely photons emanating from the sun, which can be used to propel that solar sail. Similarly, a hang glider can fly without any fuel or an engine just by taking advantage of the natural resources we're surrounded by, namely the atmosphere and the laws of aerodynamics.
To achieve sufficient speeds to tow a spacecraft supporting life forms, the sail would have to be huge, up to hundreds of miles in diameter. And because the photon pressure from a star would decrease the further the sail traveled, some have envisioned a concentrated laser beam directing energy at the sail.
Eventually, and sadly, this hang glider and all hang gliders at some point have to land. But a solar sail riding a beam of laser energy could conceivably travel to the stars.
The max speed of a solar sail? About 10% the speed of light. Travel from Earth to Alpha Centauri using laser-generated photons? About 45 years. Currently, NASA and other space agencies have plans for launching more solar sails. But there are other, more powerful sources of propulsion in the universe.
In the 1960s, a method of propulsion was proposed where a spacecraft would literally drop a series of explosive charges out the back, and the force of the explosions would push the spacecraft forward. The prototype was called the Orion drive, and there were actually a series of experiments done with conventional charges to show that it would work. The Orion drive, however, was proposed to use nuclear charges. In order to simulate an Orion-style propulsion system, Paul and Jim here are rigging up a demonstration where they're going to put a small chemical charge inside this barrel, and we're going to lift this off the ground 50, 60 feet in the air. We're going to actually calculate the energy released in this explosion and compare it to a nuclear charge you might find on an actual Orion spacecraft system. Our Orion spacecraft simulator is rigged and ready to go. We're going to light off the charges inside, blow the can up into the air, and compare that with the energy released from a typical nuclear explosion that would be used on an Orion-style drive.
The Orion spacecraft, studied at Los Alamos in the late 1950s, proposed nuclear fission as its propulsion source. Fission energy is produced when the nucleus of an atom splits into smaller parts, producing free neutrons and protons that release tremendous gamma-ray energy.
The explosive charge in this 35-pound barrel lofted it about 60 feet in the air. A small nuclear charge in the Hiroshima range would liberate about 27 million times more energy. Clearly, that's a practical propulsion drive for interplanetary or even interstellar travel. Because of the huge explosions that an Orion drive would require, on the back of the spacecraft, you would have a huge, thick metal plate that would absorb the thrust of the explosion and a series of shock absorbers to keep the crew from getting jolted each time the charges went off.
The max speed of a nuclear-powered fission spacecraft? About 5% the speed of light. Travel time from Earth to Alpha Centauri? About 90 years. Despite its powerful fuel source, the fission craft is actually slower than a solar sail. Boosting speed would mean turning to another, more intense nuclear reaction.
Fission technology is well known and understood, and we've been using it to generate power here on Earth for decades. But there's another kind of nuclear technology, and that's nuclear fusion.
Fusion is the power source of the sun. In the core of our sun, the temperatures are so high, atoms are moving so fast that they slam into each other, creating new elements and liberating energy.
The opposite of fission, fusion energy is produced when two atomic nuclei fuse together to form a single heavier nucleus. The result is a huge liberation of energy. A fusion-powered spacecraft was proposed in a 1970s study called Project Daedalus. Its mission called for a trip to Barnard's star, some 5.9 light-years distant. Instead of nuclear bombs, the fusion-powered craft creates the propulsion on board in a reaction chamber.
The fuel pellets for the Daedalus-class starship consisted of pellets composed of a deuterium helium-3 mix. These would have been ignited by what we call relativistic electron beams. These are extremely high-energy electrons that would have hit the deuterium helium-3 pellets, caused them to fuse, and a huge amount of energy would be released. The Daedalus design called for 250 of these pellets to be released every second for over 2 years. The spacecraft would have weighed 55,000 tons, most of which would have been fuel.
The weight penalty for such a spacecraft would be high, but an advanced civilization could eliminate the problem by mining the hydrogen fuel during its interstellar journey. Deuterium, or heavy hydrogen, exists in abundance on Earth, notably in seawater. But helium-3 is a much rarer isotope. In our solar system, it can be found on the Moon, and in vast quantities on Jupiter and Saturn. Scientists have proposed using huge hydrogen scoops to mine the helium-3 needed to cross the void of space.
So it's conceivable that if you had a craft that was powered by nuclear fusion, you could go to another star system and then use the hydrogen available from that star to refuel.
The self-contained, fusion-powered spacecraft could avoid a huge weight penalty and reach speeds that could allow near-star exploration in a reasonable time frame. The max speed of a nuclear-powered fusion spacecraft? Up to 15% the speed of light. Travel time from Earth to Alpha Centauri? About 35 years. The immense costs, the logistics, and even the politics of nuclear-powered spaceflight long ago caused humanity to scrap any and all plans. But a sufficiently advanced society could trade nuclear propulsion for what seems like an impossible paradox, traveling at light speed without moving at all. Can UFOs actually achieve the immense speeds required for interstellar travel? One potential answer may be buried 30 feet beneath the ground in America's heartland. The Fermilab Tevatron Collider, outside Chicago, Illinois. Racing just below the speed of light, particles of protons and antiprotons are launched in opposing directions. They meet in a high-energy collision. The impact produces gamma rays, the highest energy source known in the universe, and potentially the key to interstellar travel.
The best way of making antimatter here on Earth is to employ probably the most famous equation that Einstein taught us, which is E equals mc squared, which tells us that for a certain amount of matter we can get energy. It's a great idea because it's incredibly efficient. You essentially take all of the mass in those particles and convert it into energy.
But how can antimatter exist in the universe if it must be artificially manufactured? That's the question that Stephen H. from Philadelphia texted the universe.
Stephen, antimatter definitely exists, and when it meets up with normal matter, it explodes in a burst of electromagnetic radiation. Now, we can make small bits of antimatter in laboratories, but we can also collect antimatter from space. Some cosmic rays, which are charged, very energetic particles coming from space, actually consist of antimatter.
Currently, the super collider is the only practical way to produce antimatter. And right now, it's created in very small quantities.
If we could figure out a way to both create and store enough antimatter, we would have a storable fuel which, when mixed with ordinary matter, would liberate a huge amount of energy at a rate way beyond what either fission or fusion can do.
Because we know antimatter exists, and we know antimatter can be created and stored, it is conceivable that an advanced civilization could create and harness the power of antimatter in sufficient quantities to create an antimatter rocket.
An antimatter ship could achieve unbelievable velocities, cruising just below light speed, nearly matching the speed of a starbeam streaking across the galaxy. Travel time from Earth to Alpha Centauri, 4.5 light years distant, about 5 years. In human terms, the cost of creating enough antimatter particles to power such a starship would be astronomical. It might be affordable in alien currency, but an antimatter spacecraft like this comes at a high price. The gamma rays from antimatter propulsion are so dangerous, they could destroy the cell structure of any living beings aboard ship. This starship would have to include an advanced shielding mechanism to keep the crew alive. And at such high rates of speed, there are equally destructive threats in the universe.
Space is pretty empty, but if you were moving close to the speed of light, you'd need an extremely effective shielding system that would allow you to be protected from interstellar dust particles that would all but annihilate a spacecraft traveling that fast.
But if space debris is so dangerous, why not avoid it completely? The solution might be one familiar to Star Trek fans, namely a starship that could achieve light speed without even moving.
In effect, one would create what is called a warp bubble, the name taken straight out of science fiction, and that would involve compressing a region of space-time in front of a spacecraft and expanding a region of space-time behind a spacecraft, while the spacecraft itself sat stationary inside this flat bubble. And one would effectively be riding a wave of space-time.
A warp drive may seem like pure sci-fi fantasy. But in 1994, a well-respected young physicist named Miguel Alcubierre published a serious proposal outlining how to travel in a controllable space warp. There are huge obstacles to Alcubierre's warp drive solution. The biggest is called dark energy, a cosmic phenomenon recognized in 2011 when 3 scientists were awarded the Nobel Prize for proving its existence.
The simplest explanation that's been proposed for the phenomenon of dark energy is that there's an intrinsic property of space itself that makes it want to expand. You can actually see it by looking at receding parts of the universe and seeing that there's this extra acceleration component. But it isn't a stored energy source like solar energy or other kinds of energy.
And so it's not inconceivable, it's not beyond the realms of possibility that some advanced civilization existing somewhere in the universe has learned how to harness dark energy to create an exotic form of propulsion.
But there's another obstacle to a workable warp drive. The only known way to pull a spacecraft forward within a warp requires harnessing the intense energy of a black hole.
The sort of simple notion is somehow to make a very concentrated bit of matter, extremely concentrated on the level which would cause a black hole. If you could generate a black hole on a small scale, so to speak, you could dangle it in front of the ship and use its space distortion to sort of drag the ship along.
And exactly how fast could a warp drive tow an extraterrestrial spacecraft?
The clear implication of Alcubierre's work was that it should be possible, if you can make this design of a warp drive, to achieve speeds almost any multiple of the speed of light.
Travel time from Earth to Alpha Centauri aboard a lightspeed craft powered by a space warp? About 4.5 years, or less, as long as everyone on board doesn't incinerate.
One problem with the Alcubierre drive is within that warp bubble, temperatures would rise to far hotter than the core of our sun. That's hot.
Just one more small problem to solve for the chance to reach planet Earth. But what if such an alien spacecraft were to arrive in Earth's atmosphere, riding in a warp bubble towed by a black hole? It might not be the first mass witness UFO sighting, but it would certainly be the last. March 13th, 1997. Thousands of people witness an optical phenomenon drifting across the Arizona skies. Reports of a series of bright lights in geometric patterns are widespread, including multiple sightings over Phoenix of a craft up to 1 mile wide with lights winking on and off in sequence.
Reconstructing the events of that evening, the lights of the Phoenix lights were almost certainly flares dropped by an Air Force A-10 aircraft in conjunction with the human tendency to envision a solid shape connecting them. That's the best explanation for the Phoenix lights.
For many, the Phoenix Lights incident was direct proof that a huge extraterrestrial craft had arrived. Some even called it a mothership. The purpose of an extraterrestrial mothership is fundamental to the theories of alien visitation. It's the only way to bridge the vast distances of interstellar space.
The term mothership, I think, came into being around the same time that flying saucers as a term came into being. And I think the universal notion was you couldn't make an interstellar trip in a person-sized craft. You had to have something really large.
An apt earthly analogy of a mothership is that of an aircraft carrier. An aircraft carrier travels the vast distances across the oceans, but its purpose is to transport smaller aircraft which can then go on and engage in whatever their missions may be.
If the journey to Earth is long, on the order of centuries or even millennia, the mothership would be much more than just an aircraft carrier.
There's the generational or ARC ship, which is a very large spacecraft that is essentially an enclosed ecosystem in which generations of inhabitants expect to be born, grow old, and die over the long period it takes the spacecraft to reach its ultimate destination.
Perhaps with technology such as suspended animation, biological alien passengers could be put to sleep and revived after the vast journey. Surviving such a journey would also mean surviving the destructive energy powering the spacecraft itself. One logical design solution, a cigar-shaped mothership, is precisely what many UFO witnesses claim to have seen.
For any advanced propulsion system, you would want to situate the crew as far away as possible from the engine source. So one possible design would be a very long, thin design with the engine located at one end of the spacecraft and then some kind of truss connecting the crew section as far away as possible so as to avoid damage from high-energy neutrons, X-rays, or gamma rays from the advanced propulsion system.
If such arc ships have in fact visited planet Earth, the evidence would be overwhelming and undeniable.
Something all these exotic and advanced propulsion technologies have in common is that they all radiate prodigious amounts of energy, and so we'd be able to see them like beacons on a lighthouse from sometimes light years away.
A concentrated emission of X-rays, gamma rays, or subatomic particles would be suspicious because we don't see that in our environment locally under any normal circumstances.
Beyond the obvious visual evidence, the physical effect of a mothership approaching so close to the Earth's surface could be a terrifying form of apocalypse.
If, for whatever reason, this extraterrestrial technology or civilization chose not to turn off their engines, it could be catastrophic for life on Earth, as we would be bathed in high-energy neutrons, X-rays, and gamma rays.
If it's something which is a version of a warp drive, then you're talking about space distortion. And you wouldn't want to be too close to any major mass, including a planet.
Such catastrophic visitations assume that aliens are willing to risk their own lives in interstellar space. But there might be a better way. They could stay at home and explore the cosmos using a race of thinking machines. For many ardent believers in the UFO phenomenon, the Roswell, New Mexico event in the summer of 1947 is the defining alien encounter in human history. In popular culture, the most lasting detail from the purported crash came from the descriptions of extraterrestrial bodies found at the scene. In the ensuing decades, this vision of alien beings, known as the Greys, became the accepted standard in science fiction and recurring alien encounter reports. The oversized heads may explain an expected feature in alien biology: greater intelligence. The larger skulls would contain larger, more advanced brains compared to ours. Mastering the profound challenges of interstellar travel would certainly require great intelligence, but might it require something that is beyond organic biology?
One area of science fiction where we might be making kind of a big mistake is to assume that the aliens are biological, that they're living things.
I think that the possibilities for the kinds of organisms which might travel between the stars are really wide open. And one possibility that has appeared on occasion in science fiction is machine intelligence.
According to a recent earthly equation known as Moore's Law, the number of transistors on a single computer chip doubles every 18 months, meaning computer processing speed doubles. This trend has continued for more than half a century and is expected to continue through 2020 or later. The exponential explosion of processing speed is opening the door on a staple of science fiction called artificial intelligence.
So if you invent a thinking machine, 100 years later, that machine is not only smarter than you are, it's smarter than all humans that have ever lived. And that's the difference between artificial intelligence and real intelligence. Artificial intelligence can evolve enormously faster. But I think the form of AI that we find most both menacing and promising is the kind of AI that could, in fact, do what our brains can do, and think the way we can think.
At Stanford University's Artificial Intelligence Laboratory, the future of truly intelligent machines is rapidly approaching.
There are a few things that make AI difficult. One is we don't really know yet how to make computers learn as effectively as humans can. It seems that our computers today just aren't as fast as we would like them to yet to simulate the learning processes that take place in the human brain.
To demonstrate early-stage artificial intelligence, Stanford students designed a fighting robot, one that attempts to learn as it fights.
Okay, so what it's doing now, it's trying to defend itself. So it's reacting to your motion. So depending on how you move your sword, the robot will adapt to your motion and to your behavior.
How important a step on the road to true artificial intelligence are robots like this, Thorsten?
So here we are using artificial intelligence methods, like learning methods, to adapt to the environment of the robot. But we are still not at a stage where the robot is really thinking.
Today's computers are still far less intelligent than almost any human, but in the future, I think computers could eventually reach and maybe even surpass human intelligence. And if that's the case, imagine that each of us had a computer in our wallet, had a cell phone in our wallet that was as smart as Einstein or even smarter. How would civilization change, and what are the amazing things we could do then?
Advanced as it is on Earth, the fencing robot is but a crude analogy for the type of machine intelligence that could pilot an interstellar spacecraft. The immense obstacles of space travel, including the sheer timescale and cosmic hazards, build a strong case that a race of intelligent machines will make first contact.
But honestly, if interstellar travel really takes place, it seems sort of reasonable to not send the biological beings. I mean, they're fragile. They have finite lifetimes.
Just as NASA sends robotic probes to explore the solar system in advance of human explorers, our first contact with an alien civilization may be with its robotic probes.
Biologic being or AI super being? Our vision of an extraterrestrial will remain mere speculation until first contact is made. But how long will we wait? And despite a lack of hard evidence, just how likely is the existence of another intelligent civilization? Some believe it is highly likely that the universe teems with life.
The galaxy has been around for a long time. The solar system has been around for quite a long time, but the galaxy much longer. And the stars in it, many of them are much older than the sun and our solar system. So the chances are civilizations are out there. They've been around for longer than we have. If they exist, say, for 100,000 years, then the chances are pretty good. I think they will have learned to either communicate across interstellar space or possibly travel.
Until first contact occurs, humanity will continue to scan the skies for UFOs.